Hey, welcome everybody to this week's installment of video notes for Mr. Flugum's physical science class. These notes will go on page 4 in your notebook. You may not have your notebook by now. Remember, you don't have to have that till Thursday or Friday in class. If you don't have a notebook, just put the notes on a separate piece of paper and we'll tape it in later. Alright? Well, today we're talking about speed and velocity as well as other things, and one of the big themes of this unit is going to be describing how objects move. So what is their motion like? And that not only includes how fast they're going, but also how far and what direction. So that's all of the things that we're going to be talking about today. Alright, well, let's start with something simple, distance versus displacement. I think you guys already have a pretty good idea of what distance is. Alright. We can measure that in lots of different ways and lots of different units depending on how big the distance is. But displacement is another idea. You can see there that that displacement not only includes distance, but it also includes direction and a starting point. So, if you see there in the picture, there's two guys and they meet on the street. One guy has an umbrella and it's raining. He has a longer ways to go. The other guy has no umbrella. He has a shorter ways to go. So the guy with the umbrella walks another 40 meters. That's his distance. The guy without the umbrella goes 10 meters. That's his distance, right? How far they went. Now we got to talk about displacement. Displacement also includes the direction. Now in this case, we've got a little scale there where their meeting point is 0, and we have positive numbers going to the right and negatives going to the left, just like a number line, right? So if we look at the guy in the umbrella, his displacement is positive 40 meters. Whereas the guy without, his displacement is negative 10 meters. So now not only have we shown how far they are from where they started, we also show what direction it went from the starting point. Alright, so speed. Speed is the next simplest way we can describe an object's movement. Speed is kind of like how fast something's going, right? Well, there's two kinds of speed measurements. One is called instantaneous speed. All right? So instantaneous speed there is the speed of an object at a given moment, just like it says. So if you're driving in your car and you want to know your instantaneous speed, you will look at your speedometer. If it says 50 miles per hour, that's your instantaneous speed. That's how fast you're going right now. Okay? There's other ways to measure instantaneous speed, maybe if you have like a radar gun or something like that. Second measurement of speed is average speed. This can be found pretty easily. Speed is equal to distance divided by time, right? So if I go 100 kilometers in 2 hours, my average speed is 50 kilometers per hour, right? 100 kilometers divided by 2 hours. Units for speed are always a distance-time combo, and there's lots of them. I gave you a few examples here. The first one is meters per second, the m/s there. That would be the most common one we'd use in physics because those are the most basic units. But you could also use things like kilometers per hour or centimeters per year if you're measuring the movement of a tectonic plate. You could also measure things in kilometers per second if you're measuring something really fast, like the speed of light. Now, do this for me. You can do it in your head if you like. So if you have a person who sprints 100 meters in 10 seconds, what is their average speed? I'm sure you can do that. Many of you can do that in your head. But here's the important thing. What are the proper units for labeling that speed? Think about it and write down your answer. We'll talk about it in class on Thursday or Friday. Alright, well, let's wrap this up with one last idea, velocity. This is probably the most important thing we'll talk about. You need to understand the idea of velocity. Velocity is kind of like speed, except velocity is specific about the direction. So for example, if you have that skier there and he's traveling 3 meters per second east, that's a velocity because we include the direction in it. So big question is this. Can you change velocity without changing speed? What do you think? Can you? Actually, you can. If I change my direction, but not change my speed, I can change my velocity, right? For example, if that skier is going 3 meters per second east, and then he turns gradually without slowing down so that he's going north. Now he's changed his velocity, but he's still going 3 meters per second. The speed hasn't changed. This is a really important idea for you to wrap your head around because velocity relates to a lot of ideas in physics, like acceleration and momentum. So it's very important that you remember velocity. I hope you guys have a great day, and I will see you on Thursday and Friday in class.